The Automated Podcast.
Welcome back to Automated. This, of course, is the podcast looking at the impact of technology on jobs. And again, I'm your host, Mark Verbenkov. So before we jump into today's topic, which is going to look at robots and their relationship with our jobs, I wanted to briefly mention that I've had a couple questions that go beyond the content of the episodes. So if you want to reach out, you can always find me via Twitter or LinkedIn just by searching Automated Podcast. But let's look at where robots came from to start off with. So robots, or at least the initial idea of them, have actually been around for a lot longer than some of us might actually think. So in both Greece as well as China, as far back as 300 BC, both autonomous beings as well as animals were actually initially conceptualized. However, much later, Leonardo da Vinci, for instance, in around 1500, had sketches for a mechanical knight that would have actually been capable of very simple movements, such as like head movements or basic arm movements. But it wasn't until 1921 that a Czech writer coined the term for a play, where the plot actually revolved around a man who makes a robot and then is subsequently killed by it, not unlike many of our media productions today. But the term robot itself comes from the Czech robota, which was used in the play itself, and this means forced labor, which is especially fitting for our topic in this podcast. However, modern robots as we know them today didn't really come around until the middle of the 20th century, when the first electric autonomous robots were made actually in England in 1948 by somebody named William Gray Walter, and resembled slow-moving turtles. So these turtles, or tortoises, were actually named Elmer and Louise, and they simply prattled around, and when their batteries ran low, they were actually able to find their way back to the charging station. But it was in 1954 in the US when George Devol made the first industrial robot that was then sold to General Motors in 1960. So this robot was called Unimate, and it looked pretty similar to today's industrial robots, though it was certainly less agile. So it had a large base, and it was then attached to a movable hydraulic arm that had a gripper at the end, which could be changed for different operations or different tasks. If you're curious, I'll put a link to a picture in the show notes. So with this first robot's adoption, we can already kind of see a couple glimpses of the value of industrial robots in general. As Unimate was working in General Motors, it was initially tasked with actually lifting hot pieces of metal and stacking them within the automotive plant. Later on, it would then go to welding certain parts in an assembly line onto the cars themselves. And this work was actually pretty dangerous, as human workers would be susceptible to being poisoned by the toxic fumes or even losing a limb. But over time, robots have greatly improved, and though they are still predominantly used in manufacturing today, they have really diversified. So the International Federation of Robots, one of the many associations out there connecting both robotic companies as well as researchers across the world, breaks robotics into two main categories: industrial as well as service. We'll look at industrial robots specifically in this episode and leave service robots for the next one, as they are significantly more diverse and cover other robots such as exoskeletons or drones or autonomous guided vehicles, etc., etc. So though there are many variations of industrial robots today, the more classic and widely used form is something that's called a articulated robot. And this just simply means that it has multiple joints, allowing it to move in many different angles, and typically takes the form of a single arm, similar to the Unimate as mentioned previously. Of course, they're programmable and usually perform a very specific task within the industry that they're working in. So currently there are really 5 major markets for industrial robots. There's China, Japan, the United States, South Korea, and Germany. And these 5 main countries account for about 74% of all global robot installations. But maybe we should pose the question as to why it is that robots are so often used as the main example of a technology when we have discussions about humans versus machines, especially as it relates to jobs. So this is actually quite linked to a point from a previous episode where I was talking about technology as being used throughout history to replace human physical capabilities. And I really think that robots are perhaps the current best example of this trend. So there are actually many aspects of robots that can be thought of as being the kind of crux of reducing human physical capability, but it can really be generally boiled down to about three main ones: speed, accuracy, and repeatability. So to give you a bit of an idea of the differences, if you're sitting down right now, try picking up your cell phone or any object that's in front of you and put it down at your arm's length. Now do this a few times rather quickly and try to put it down in the exact same spot you put it down the first time. So you might actually be pretty accurate and only off by a few centimeters. Now go ahead and do this 3,000 times without stopping. So I'd be willing to bet you're probably a little less accurate as time goes on and most probably not going to finish. When we talk of robotic accuracy, we typically measure the accuracy in millimeters or fractions of millimeters, not centimeters. And when we talk about speed, that action that you did about dropping and picking up your phone or object, this is generally considered to be done at a maximum of about 1.6 meters per second. The metric isn't important, but what is important is to compare this with one of the newer robotic examples. This is a Kawasaki robot that can move at about 12,000 meters per second. I can also post in the show notes a link to a really short clip of the robot moving back and forth. I'm not sure if it's at exactly 12,000 meters per second, but it's still pretty fast and can give you a good idea of the speed that we're talking about here. So when we're talking about repeatability, 3,000 times of doing this action wouldn't even make a commercial robot break a sweat. And we're talking about doing this with near perfect precision at these incredible speeds. So hopefully this should give you a decent picture of basic industrial robot capabilities. There are lots more, like degrees of freedom it can move in, the payload it can carry, and not to mention the lack of need for breaks or sick days or holidays, etc. For this reason, I hope it's really easy to understand that there are now some 2.5 million industrial robots in use across the world, with over 400,000 being installed just last year. So my goal here really isn't to bore you with a bunch of statistics about robots being bought and used, as well as their capabilities, but it's really to just give a picture of a growing trend, especially as most of us don't work in a factory and don't physically see these robots invading our workspaces on a day-to-day basis. But if you do work in a place that's currently adopting a robot, I'd be very curious to hear about it. So the next question that follows this is, what specific impact has this robot invasion had on the manufacturing industry? So as you can imagine, it has not really been a positive one for human employees. Even though industrial robots can and do expand the need for employees, this is done by creating many more efficiencies in the production of whatever's being produced itself. A report that was looking at robot adoption in the EU specifically actually found that there was an overall decrease in workers when more of these industrial robots are adopted. But this kind of makes perfect sense, no? As outlined before, workers are really easily displaced from specific tasks where humans cannot compete against these robots. The same, of course, is happening in the United States and elsewhere in the world, but perhaps even at a greater extent. So in the USA, between 1980 and 2017, there are about 7.5 million manufacturing jobs that were actually lost. Of course, globalization and offshoring manufacturing factories to nations with cheaper labor has a really large part to play. But even the businesses that do stay are changed radically forever. So one of the main things here is that low-skilled work is really not in demand anymore in these factories, as it has really continually been replaced by high-skilled labor. Some of the examples of this are engineers, software developers, as well as computer programmers. So these jobs require more cognitive skill, which industrial robots aren't capable of automating. But that's the job for artificial intelligence potentially, as mentioned in the previous episode. But let's not go back to that here. However, to put all of this into context, what has been described so far is only relevant for first generation industrial robots. So since the turn of this last decade, a new second generation of collaborative robots has actually been on the scene, which possibly turns around this story. So one of the main problems with this first generation of robots is that they were practically deaf, blind, and dumb. So the robots actually had to be put in large mesh cages so as not to slam into human employees working in close proximity with them, and it has unfortunately caused injuries and even deaths. But with the advent of cheaper and smaller sensory technology, this new generation of what we call collaborative robots or cobots is able to sense their human coworkers nearby and either slow down their actions or stop altogether if they feel any physical contact. So another aspect of this is that they're actually very easy to program, as they're supposed to be able to shift between tasks quite quickly. So I was lucky enough to go to a conference 1 to 2 years ago and actually interact with and program one of these cobots on the spot with what was essentially a modified tablet. I was instructed to bump into the robot as it was picking up its little block and depositing it into the indicated bin. So I held out my arm in the path of the cobot, and after it picked up its little block and moved again towards the bin, it started to slow down and stopped right after giving my arm a very gentle bump. So I think that this is actually pretty impressive, especially as it offers the ability for potential factory employees to remain on the factory floors themselves, train the cobot, and work with the cobot so that it can take over the more mundane and repetitive tasks. However, as it currently stands, cobots only make up roughly 1% of all industrial robots right now. But possibly by 2027, as much as 30% of new robots sold could actually be collaborative ones. Along with many other technologies, the implementation of cobots has actually been connected to this trend of reshoring manufacturing. This is where companies are bringing their manufacturing processes back to the industrialized parts of the world, such as the USA as well as Europe. So this has a twofold impact. First, of course, this increases the amount of jobs within manufacturing in these parts of the world, as well as alters the skills needed of workers, as cobots can undertake, as I mentioned before, a number of the more repetitive, mundane tasks. But this lets human workers focus on the things that are still challenging for robots and AI, such as quality control. But to switch gears here for a second, and though not really objectively considered robotics, it would be really amiss if I didn't mention Industry 4.0 in this topic. So as many of you most probably already know, we are now considered to be within the fourth industrial revolution, which can really be seen as the start of the blurring between the physical, digital, as well as biological borders. And this is really underpinned by greater technological speeds than in any of the three previous industrial revolutions. However, a subset of this revolution is Industry 4.0, though the two terms are used synonymously many times. Industry 4.0 specifically looks at industry and includes the connection between the industrial physical technologies like robots, along with digital ones like the cloud or big data or the concept of Internet of Things. So this larger idea really enables businesses complete environmental awareness of an entire production process and enables a number of different benefits like the replacement of machines before they wear out, find different unknown inefficiencies, and even remotely manage a factory. So this might, however, enable the first generation of robots to be seen as a potentially viable path of the future, as many workers might interfere with a highly connected and digital process, although this isn't for sure yet by any means of the imagination. So though there are various forecasts, it really is still unknown whether cobots will overtake traditional robot adoption in the years to come, or with the linking of these other industrial technologies, pure automation of manufacturing will make more sense. So if you have a strong point of view either way on this, I'd really like to hear about it. And that's it for this episode. As always, thank you very much for listening. Make sure you subscribe and rate or review the podcast on iTunes if you have a minute. If you want to but aren't a Mac or iTunes user, you can go to the website automatedpodcast.org, and there's a quick guide to help you out on the blog page.
The Automated Podcast.